There's another game you can play with these rods that's more difficult to play with apples. For example, this is a rod, okay? Now, at the moment, it's not been given any more name than just a yellow rod. I could, if I wanted to, call this 1. If I call that 1, then this one here would be worth 5. Okay, so if this is 1, this is worth 5. But I've played a game there. I called this 1. And that is what most people would normally tend to do. They would tend to call this 1. But because these little rods haven't actually got any marks on them at all, you could, if you wanted to, call this one 1. Now that is a whole new fantastic ball game that you can play. Because they have no marks on them, I'm saying it again, you can call this whatever you like. So I could call it 1 or 2 or 3 or 4 or a million or a trillion, or I could call it a nanometer. I can call this anything. So this can, if I decide to play this game, represent any number. That's good. And that means that this thing here can represent, if I decide to play this game, an infinity of numbers. This represents all numbers if I decide to play this game. In a kind of a way, this apple here, it represents all apples, or it could do if I decide to play that game. I mean, all apples aren't the same. Some will be green and yellow and big. Some will have little worms in them. I mean, grubs, they'd be lying on the ground rotting. There'd be like billions of them in orchards all over the world. And they're not all exactly the same, but if I wanted to, I could allow this apple to represent all apples. But at another level, it's a bit hard to call this 2 apples. This here, I could call it anything I like. It's the same in a way, but with an apple it seems a lot worse to call this 2. It seems to be kind of defeating the object in a way. You could do, but this one here, I can call it anything, okay? Just think about it. They both in a way represent an infinite group of other things. This can be any number. This could be any number, but because it's a kind of real thing that we eat and so on, probably, it's kind of like, basically like 1 apple. It's a whole, it's 1 apple. This is a whole as well, because it's a bit more abstract, I suppose, and we don't really eat them or do anything with them, it's easier to call it anything. And because its friends as well are kind of like ordered in a nice, lovely, easy way, they're all exactly the same bit bigger than all the others. It's easier to play games with these than with apples. That's all I'm saying. You could call this 3 apples if you like, but people would think you were crazy. But if I call this 3, I mean, you know, it's more likely that you would accept that I could call this 3. Why not? The beauty of these rods is, for measuring devices, you can call them anything you like. You can start with any rod and call it anything you like. In that lies the power of these rods. This rod here represents, could do if I play the game, any number. I could call it, for example, the square root of 2. I could call it the square root of 2. Now that sounds a bit weird, but because I can do that, there's immense power here. So if I call this the square root of 2, I'll tell you what, I'll make something which equals the square root of 2. If I put these two little rods next to that one, you can see that it comes to the same amount as the square root of 2. So this one plus this one is the same as the square root of 2. But what is this one here then? This is 1/5 of this. So this one here is 4/5 of this. So straight away, you see, I've gone into another world. Like the square root of 2, that's this one, is equivalent to 4/5 of the square root of 2 plus 1/5 of the square root of 2. This is it. This is Cuisenaire rods at work. I'll write it down a bit differently. The square root of 2 is 4 root 2 over 5 plus root 2 over 5. Isn't that nice? Well, I think it's nice. This thing here, we're playing a game with it. We're playing a game. I'll just stop for a moment. The game that I'm playing is, what can I see in this? That's all the game is. Many people would say that 4 and 1 makes 5. That's true, but that is one of the infinite number of games you can play with these rods, and that is why they're so powerful. This thing here, a little tiny pattern of 3 rods, can represent whole worlds. It just depends how you look at it and what games you play when you're calling it something. But this is a generalized form of all kinds of specific things. What you're looking at is the algebraic form of an infinite array of possibilities. These little things are representatives of the generalized world of algebra. These things will transform everyone's ability to think about maths if you play the proper games with them. These things are the Zen rods. No, let's put it in a different way. Zen is the art of perceiving that form emerges from emptiness. This is the Heart Sutra. I'm not trying to persuade you to become a Zen Buddhist, but out of emptiness comes form. This, if I choose to, I can call it whatever I like. This is Zen and the art of maths.